this example, we need to find out the equivalent resistance in a parallel circuit. We have two different cases. So case 1, we have 16 ohm and 8 ohm connected in parallel. So it's going to be something like this. So this one is 16 ohm, this one is 8 ohm. So 1 over RT equals to 1 over RI. So that's the formula to find the equivalent resistance in parallel circuits, which in this case, since we have two resistors, it's going to be 1 over R1 plus 1 over R2. So 1 over RT equals to 1 over 16 plus 1 over 8. Since we have two different denominators, when you add them, you need to use the common denominator. So you need to multiply numerator and denominator by 2. So 1 plus 2 is going to be 3. So RT, you need to flip this one because this one is 1 over RT. So it's going to be 16 over 3. That's going to be 5.33 ohm. That's the answer to part A. To part B, we have 3 resistors in this case, 22, 12, and 5 connected in parallel. So it's going to be something like this. So 22 ohm, 12 ohm, and 5 ohm. So 1 over RT equals to 1 over R1 plus 1 over R2 plus 1 over R3, which is going to be 1 over 22 plus 1 over 12 plus 1 over 5. So in order to add these things, we need to find out the common denominator R of the denominator. So it's going to be LCM, least common multiple. It's going to be 660. 660 divided by 22 is going to be 30. 660 divided by 12 is going to be 55. 660 divided by 5 is going to be 132. So 132 plus 55 plus 30 is going to be 217 over 660. So RT, you need to flip it because we calculated 1 over RT. Is going to be 660 divided by 217. So 660 divided by 217 is going to be 3, almost 3, approximately 3 ohm. Another method you could use here, instead of using fractions, you could use decimals. 1 over 22, 0.045 plus 1 over 12, 0.083 plus 1 over 5, which is going to be 0.2. Then you add them all. It's going to give you 0.328. Then you need to inverse both sides. It's going to be 1 over 0.328. That's going to give me almost 3 ohm.